Hello students, in today's video we will be discussing chemistry questions of WB-JEE exam which was held in 2020. So let's start with the questions part. So in this question we have 5 ml of zero point 0.1 molar lead nitrate mixed with 10 ml of 0.02 molar potassium iodide, and we have to find the amount of PbI2 precipitated in this solution. First we have to write the reaction that is taking place. So the reaction between lead nitrate and potassium iodide gives lead iodide and potassium nitrate. So to find out the number of millimoles which is present initially in this solution. So initially we have lead nitrate which is equal to 0.5 millimole, and for potassium iodide we have 0.2 millimole. So we can see that the 0.2 millimole is in less quantity, so it will be acting as a limiting reagent. So potassium iodide is our limiting reagent. So after the completion of this reaction, the potassium iodide which we are left is 0. So from this equation we can see that potassium iodide 2 moles yields 1 mole of PbI2. So 0.2 moles or millimoles of potassium iodide will yield 0.1 millimole of lead iodide. So we have to find moles of lead iodide precipitated. So we will divide the millimoles divided by 1000, and the answer will be 10 to the power of -4, which is option number B. So let's move to the next question. In this question we have to find that out of these four options, that is these four gases, which is the gas that is present in the system which has density of 1.964 gram per liter and has a pressure of 76 centimeter of Hg and temperature is 273 Kelvin. Now we know from the equation that molar mass is equal to D stands for density into R into T, where R is universal gas constant, T is temperature and P is pressure in atm. So M will be equal to density which is given as 1.964 into R, that is 0.0821, temperature which is given that is 273, and pressure in atm will be equal to 1, that is 1 atm is equal to 76 centimeter of Hg. So to convert it in atm we have to divide it by 76. So 76 by 76 the pressure will be 1 atm. So mass of the gas which is coming out is equal to 44. So 44 is the molar mass of CO2. Hence our answer is option number D. In this next question, we have to find the molality of this solution, and we have given the mole fraction of ethanol in water. So mole fraction of ethanol in water is 0.08, and we know that mole fraction is equal to number of moles of ethanol divided by number of moles of ethanol plus number of moles of water, which is equal to 0.08 divided by 1, which is already given in the question. So we can write that Na plus Nb is equal to 1 and Na is equal to 0.08. So we can find that Nb is equal to 1 minus Na, which is equal to 0.92. Now we have to find the mass of H2O, that is the mass of the solvent. So mass of solvent is equal to 0.92 multiplied by 18, where 18 is the molecular mass of water, that will give 16.56 gram. So to find molality we have to first write the formula of the molality, that is equal to moles of solute, in this case it is ethanol, and the mass of solvent, that is water, in kg, that is equal to 0.08, that is Na. Na was number of moles of ethanol, that is 0.08, divided by mass of solvent, which is 16.56, and we have to write in kg. We have to multiply it by 10 to the power of -3. On solving we will get 4.83, and the answer is option number B. Moving on to the next question, we have to find the fraction of total pressure exerted by hydrogen. So in order to find that, first we have to see what is the number of moles of hydrogen and number of moles of ethane. So in the question it is already given that they both are having equal masses. So let's say their masses is equal to x gram. So number of moles of hydrogen will be equal to x by 2 and that of ethane will be equal to x by 30. We have to find the fraction, and we know that partial pressure of hydrogen is equal to mole fraction of hydrogen multiplied by total pressure. Okay, so in fraction, for the fraction which we have to find, that will be equal to partial pressure of hydrogen divided by total partial pressure, which is equal to mole fraction of hydrogen. So for mole fraction of hydrogen we have number of moles of hydrogen divided by total number of moles, which is equal to x by 2 divided by x by 2 plus x by 30. On evaluation, that will give the value of 15 by 16. So the answer is option number A. Moving on to the next question. In this we have to find that which among the following options is correct. So in order to do that, we have to see that this is the adiabatic process. So for adiabatic process, we know that dq is equal to 0. That is the heat exchange in the system. So heat exchange in the system is 0. For expansion against vacuum, the external pressure which is applied, that is equal to 0. So work done in this case is equal to minus of P external into delta V, which will be equal to 0. So on applying the first law of thermodynamics, that is d is equal to dq plus of dw, we have now dq is equal to 0 and dw is also equal to 0. So dE, which is the internal energy, or we can sometimes you write dE as du also. So for internal energy we have two symbols, either E or either U. You can write any one of those. So dE or dU will be again equal to 0. So we can say that the internal energy for the system is 0. If du is equal to 0, then delta U will also be equal to 0. Hence our answer is option number C. In the question number 16, we have to find the temperature at which ice begins to separate from this mixture. So basically we have to find the freezing point of this solution. So before finding the freezing point of this solution, first we have to find out the molality of this solution. So to find this molality, we have to start with 10 mass percent of ethylene glycol. Let's see what does 10 mass percent means. 10 mass percent of ethylene glycol means that 10 gram of ethylene glycol is dissolved in 100 gram of the solution. So in order to find the mass of solvent, in this case which is water, that will be equal to mass of solution minus mass of the solute, that is 100 minus 10, which is equal to 90 gram. Now we have to find the molality, moles of solute divided by mass of the solvent. So moles of solute is equal to 10 by 62, where 62 is the molar mass of ethylene glycol and 10 is the mass which is already present in the solution, and the mass of solvent is 90 grams. So in kg we can convert as 90 multiplied by 10 to the power of minus 3. On calculation it will give you molality is equal to 1.79. Now we know that the formula of depression in freezing point is equal to Kf into m, where Kf is already given, which is 1.86 multiplied by m, which is molality, that is 1.79, giving out to be 3.3 degree Celsius. Delta Tf is equal to freezing point of water minus freezing point of the solution. So freezing point of water we all know that is equal to 0, and the freezing point of solution, let's consider it as x, and the delta Tf is 3.3. 3.3 degrees Celsius is equal to 0 minus x. So x will be minus of 3.3 degrees Celsius. So the temperature at which ice begins to separate from this solution is minus 3.3 degrees Celsius. So the answer is option number C. Moving on to the 17th question, we have to find out of these statements which statement is not true. So it is pretty simple question. In this we can see that the option number D is written as F is less electronegative than oxygen, and we all know that the most electronegative atom which is present in the periodic table is fluorine. So fluorine is obviously more electronegative than oxygen, and option number D, hence it is incorrect. So our answer is option number D. Moving on to the next question, we have to find the velocity of the electron in the first Bohr orbit, and the data which is given is for the radius of first Bohr orbit of hydrogen atom. So let's see first what is the formula of radius. So formula of radius is equal to 0.53 into 10 to the power minus 8 multiplied by n square by z, where n is equal to Bohr orbit and z is equal to the atomic number of that particular atom. Here z की value जो होगी that is equal to 1 since it is a hydrogen atom. So on comparing these two values, we can say that the value of n will be equal to 1. So our orbit is first Bohr orbit. Now we have to find out the velocity. So for the velocity, we have the formula that is 2.18 into 10 to the power 6 into z by n. So we know that z की value जो है that is equal to 1 since this is a hydrogen atom, and n is also equal to 1. So the velocity is equal to 2.18 into 10 to the power 6 meter per second. Now the unit which is given in the answer is centimeter per second. So we have to convert meter per second to centimeter. So multiplied by 100, which will give you the velocity is equal to 2.18 multiplied by 10 to the power 8. So our answer is option number A. Moving on to the next question, we have to find the difference between the orbital angular momentum. So before finding the difference, we have to first see what is orbital angular momentum. So orbital angular momentum for any electron in a particular orbit can be written as under root of L into L plus 1 multiplied by h by 2 pi, where h is the Planck's constant. So for 4f orbital, we can write that the orbital angular momentum will be equal to under root of 3 into 3 plus 1 into h by 2 pi. Since for f orbital, we know that L is equal to 3. So orbital angular momentum will come out to be 2 under root of h by 2 pi. For 4s orbital, we have L is equal to 0. So orbital angular momentum will be equal to 0 in this case. So the difference between the orbital angular momentum will be equal to 2 under root 3 h by 2 pi. So our answer is option number A. So let's move to the last question. We have to find the number of unpaired electrons present in the uranium atom. So to find that, we have to see the electronic configuration of uranium atom. Radon 5f3, 6d1 and 7s2. So the unpaired electrons are 5f3 and 6d1. So 5f3 we have 3 electron, and 6d1 we have 1 electron, which will be equal to 4. So the number of unpaired electrons is equal to 4. That is option number A.